Hello, everybody. This presentation will be talking about the urban heat island effect of Westfield State University. My name is Connor Gregoire. First thing we're going to talk about is what is the urban heat island effect. The urban heat island effect is a area where there is high populated areas that are warmer than rural areas. Cities with more than 1 million people have a mean air temperature of 1.8 to 5.4 degrees Fahrenheit higher than surrounding areas. As shown in the illustration to the right, why this matters. The urban heat island effect can increase summertime energy demand. Air conditioning costs can increase. It creates more air pollution. It can decrease the water quality. And it can also cause heat-related illnesses and mortality. The way we discovered if Westfield State has an urban heat island effect was doing a data research. We deployed 12 loggers, locations on and off campus, used in high concrete use locations that are mainly grassy, and areas that were woods. We used three different types of data loggers. One was the hobo pendant logger. This is the cheapest, records temperature and light. We also used the hobo water temp pro V2 logger. This measures temperature and it is also waterproof. And we also used the hobo U23 pro V2 logger. This measures temp and relative humidity. This is the most expensive out of the three, costing about $150. In order for me to determine if there was an urban heat island effect on campus, I chose to do two locations where I deployed a data logger. One was the football field, and one was in a tree on campus where there was mostly grass. On the football field, there's no grass, no shade, light exposure all day, not many structures near it, track all the way around it, and concrete surrounding. In the hanging tree, it's shaded, lots of grass, not much concrete, but some locations where there's sidewalks that there's a minimal amount. Here are pictures of where one of the hobo water temperature pro V2s was deployed. This is on the football field on the goalpost. This is the hobo U23 pro V2, and this was deployed on campus by Bates Hall and Wilson Hall, and it's hanging in a tree. So the next step was to determine the temperatures of these data loggers and what they recorded. So I determined from the day I put it out to the day I took it out to bring it back to the classroom, I averaged every single day and graphed it using Excel. And on the chart on the screen, I put the highest and the lowest temperature recorded and then labeled them directly on the chart. This is the next chart. This is from the grassy area near Bates and Wilson. Here I also labeled the highest and the lowest temperature directly on the chart, showing the difference between a 70-degree high, which was the average, and then the average of 37, which was a 33-degree difference just in 17 days. Here is a comparison. This shows that the football field is hotter on most days. As you can see, the orange line is the football field. The blue line is the grassy area. On this, I also labeled directly on the chart the highest and the lowest. What all this data means, grassy areas will be cooler than areas near artificial grass and concrete. The grassy area will cool down faster because they don't do as well as retaining heat. Westfield State could cause an urban heat island effect, but it is very unlikely. It would need to be a much larger scale, such as like a giant city. Grass will have a lower nighttime temperature. there's my works cited. Thank you for listening.